Resistors are connected in two ways. Okay, let us take three resistors R1, R2, R3. Okay, so we have to connect in two ways. If you want to get maximum resistance, we have to connect in series. For getting maximum resistance, we have to connect in series connection. Now we discuss what is series connection. Take first resistor. The end of first resistor is connected to starting point of second resistor. And the end of second resistor is connected to starting point of third resistor, which is in turn connected to battery. So first resistor R1, second resistor R2, third resistor R3. Now total potential difference is V current I. Suppose you have to connect voltmeter to measure the potential difference across first resistor V1, second resistor V2, third resistor V3. Now apply here potential difference V1 across first resistor, V2 across second resistor, V3 across third resistor, and total current I. We have to apply Kirchhoff's loop law. Take this path as A, B, C, D. A loop law for A, B, C, D, A path. Here potential difference V1 plus V2 plus V3 is equal to V. Okay. Now we know that Ohm's law. Now we have to apply equation 1. V is equal to IR, total resistance R and total current I, potential difference V. V1 is equal to IR1. V2 is equal to current again IR2. And V3 is equal to IR3. So now substitute these values in equation 1. V is equal to IR. IR is equal to V1 means IR1 plus V2 means IR2 plus V3 means IR3. Now IR is equal to total resistance R equivalent R total resistance is equal to I common R1 plus R2 plus R3. I cancel, R equivalent is equal to R1 plus R2 plus R3. This is the formula for total resistance in series connection. Now, if you connect three resistors in series, we will get maximum resistance. If you want minimum resistance minimum resistance we have to apply parallel connection. Next we have to calculate minimum resistance. If you want a minimum resistance, we have to connect these given three resistors in parallel connection. First we discuss what is parallel connection. Suppose take this is the first resistor R1, first point of this is the first point, starting point, ending point of first resistor. Take second resistor, this is a starting point and ending point, all starting point, and take third resistor, starting point, ending point. If you connect all these three starting points at one point, all ending points at one point, which is connected to battery, this connection is called parallel connection. And the potential difference V, and across the if you connect resistors, the potential difference is same everywhere. Here V, here also V, here also V. So current here I is flowing from battery, splitting into, this is I is equal I1, I2, I3. So here potential difference is same across each resistor in parallel connection. So now we have to apply Kirchhoff's junction law. Junction law at point A, junction law at point A. Suppose incoming, this is I is the incoming current approaching A, and I1, I2, I3 are leaving the current, leaving the junction I. So if you apply junction law, according to junction law, sum of incoming currents is equal sum of outgoing currents. I is equal I1 plus I2 plus I3. I is the incoming current, I1, I2, I3 are leaving current. So according to Ohm's law, I is equal V by R. Here we can say V by R, equivalent total resistance V by R1. V is same in parallel connection across each resistor. Here V by R2 second resistor, here V by R3. So V equivalent, R equivalent is equal V common 1 by R1 plus 1 by R2 plus 1 by R3. V cancel, 1 by R equivalent is equal 1 by R1 plus 1 by R2 plus 1 by R3. This is a parallel connection. So total resistance, if you given three resistors, if you connected in series, total resistance is equal R1 plus R2 plus R3. If same three resistors connected in parallel, you will getting minimum resistance. Its value is 1 by R equivalent is equal 1 by R1 plus 1 by R2 plus 1 by R3. We have to calculate total resistance. We can see the circuit here. This is a conductor which will have resistance R1 is equal to 4 ohm, lamp which resistance 20 ohm, and ammeter and potential difference 6V. We have to find total current and total resistance and potential difference across the lamp and the conductor. Now we can find total resistance. So R1 is equal to 4 ohm, the conductor and lamp in series connection because the end of conductor is connected to starting point of the lamp. So hence we can say it is a series connection. In series connection, R equivalent, our total resistance is equal to R1 plus R2. R1 value 4 ohm resistor, 4 ohm, and R2 20 ohm. So total resistance R equivalent is equal to R1 4 plus R2 20. Total resistance 24 ohm. Now we have to calculate total current. V value 6 volt battery. Total resistance R equivalent is equal to 24 ohm. So I we have to find out according to Ohm's law. I is equal to V by R 6 by 24. 1 1 the 6 1 the 6 4 the 1 by 4 means 0.25 ampere. So now we have to find the potential difference across the conductor. V at conductor. I value is 0.25 ampere and R1 value is 4 ohm. So V is equal to IR 0.25 into 4 means 100. V is equal to 100, 2.1 or 1 volt. Now V at lamp, again I value same current 0.25 ampere. I resistance R2 is equal to 20 ohm So V is equal to I by R2. Sorry, V is equal to IR 0.25 into 20, 50, 500, 3 points, sorry, 1 point here, 2.5, 50, 5.0 volt, V at lamp. So we have calculated total resistance and the current in the circuit and the potential at conductor and lamp. Next we can solve the problem related to parallel connection. So here given circuit diagram we have to solve. We have to find total resistance in this circuit and total current. Here we have seen battery which is 12 volt. V is equal to 12 volt given 12 volt, and there are 5 resistors. First one, second one is parallel, third, fourth, fifth are in parallel, and this set, this part, this is a part 1, RP1, this is also RP2. So RP1, this part and this part is in series. Okay, now we have to calculate the total resistance in this part. So these two resistors are in parallel because starting point connected same point, ending point at same point. Then hence these two resistors are in parallel. So R equivalent part 1. This is part 1, part 2. So part 1, 1 by R equivalent is equal to 1 by R1 plus 1 by R2. So 1 by R1 value 10 ohm plus R2 value, R1 they given 10 ohm, R2 40 ohm, R3 30 ohm, R4 20 ohm, R5 60 ohm. Okay, 1 by R1 is equal to 1 by R2 value 1 by 40. If you take 1 by 10 LCM, 1 plus 1 by 4. So means LCM 4, 4, 1, 1. 1 by 10 is equal to 5 by 4 plus 1, 5 by 4. Okay, 5 8s up. So 1 by R is equal to 5 1s are 5 2s are. 1 by R is equal to 4 2s are 8. 1 by 8. R is equal to RP1 part 1. Total resistance RP1 is equal to 8 ohm. Now we have to do for second part. Part 2. 1 by RP is equal to R2 is equal to 1 by R3 plus 1 by R4 plus 1 by R5. 1 by R3 value 30 plus 1 by 20 plus 1 by 60. If you take 10 as a common, 1 by 3 plus 1 by 2 plus 1 by 6. LCM as 6. 1 by RP2 is equal to 1 by 10. 6 as LCM. 2 into 2. 3, 3, 1, 1. 1 to the 2 and 3 the 3 plus 1. Okay, RP 1 by RP2 is equal to 1 by 10 is equal to 6 by 6. Cancel. RP2 is equal to 10 ohm. Here total resistance is 10 ohm. Here total resistance is 8 ohm. So total resistance is equal to, from here we can say total resistance is equal to our first part plus first part total resistance 8 ohm, second part 10 ohm, so 18 ohm. Now R equivalent in this total circuit, total resistance is 18 ohm. Now we have to calculate total current. Total current I is equal to V by R. I is equal to V value already given 12 volt by resistance 80. 4 3s are 3 4s are 3 6s are 2 2s are 2 3s are 2 by 3 total current is 0.66 ampere. So this is related to parallel connection problem. We are calculating resistance, first part, second part, and total resistance and total current. This will definitely help you. Very important question for CBSE 10th exam.